Nope. Nobody knows. Oh. Wait. Look at it. Look at it. Look at this nonsense. Look at it. Ain't right. It just ain't right. Just ain't right. Okay, here's what we're gonna do. I think I know an edge case. Okay, so here's what we're gonna do. We are going to cast a ray from here to here. No. Let's make even more of these. Hello, Chocolate Disco. These squares are voxels. And well, set that like that so it's consistent, and then we go up here, color this differently as well. Okay, so let's cast a ray from here or here to there, or to because it'll end up in the in the bottom left, right? how the... Should I cast from the middle? What if we cast like that? Yeah, that looks good. So what is this then? This is 0, 1, 2, 3, 4. Point 7. This is 8. Eight, 9, 10, 11, 12. Point 7, 8. 8, right? No, that it'll be 9. We are doing math. And we're gonna have to do more math. Let's see. Let's just start over from the beginning with the math. Oh boy. All right, so ray position, that is going to be the first one there, 4.7. Ray position equals F3 4.7 4 and 7. And we'll just go with those whole values. And then we need a ray direction. And the ray direction is, from what I understand, we do target minus ray position, right? And the target is 12, 9. That's then 8, 2. So we have 8, 2. That's our direction. And then we need the length from 8, 2. That's gonna be 64 plus 4. 66 square root. Yeah, that looks about right. Divided by ray direction equals divided by 8. Divided by 2. So that's our delta list. And that checks out because it's going very diagonally. So as you can see, it says x is 1 and y is 4, right? And that's because from here we move 1, 2, 3, and we almost move 4 before we go up in y, and then we move half an x, 1, 2, 3, and then up again. But it's slightly diagonal, so the length is more than 1 to cross, because that's what this is, right? The value is distance to cross into the next, or distance to increment that axis. So the higher the value, the less often it's incremented. But that's also the crux of the problem that we're having, I believe. We'll see if we figure that out. Ray step is obviously 1, 1. And then we need the side dist. I think we don't need to calculate the brick. We can ignore that. Side dist equals... Well, we can honestly skip this part because ray dist is this. Or side dist is that. I've already calculated that before. And I know that it's the distance to the edge. And since we are at the very bottom left of the left edge, that's just gonna be the distance. The distance is the delta. And then we can just go straight over here. And then we do mask is equals, and there it is. The mask we do less than equal, and it'll just check both sides against each other. So it really just gets the lowest or smallest side. I kind of don't get why it does this. Like, this is so overcomplicated, isn't it? Well, no, I understand why. Because what you want is, you just want the lowest value, right? But we need to know which axis is lowest. So that's why they're doing it this way. They're comparing all the axes against each other. And then we end up with one that's true and the other two are false. And then we can just multiply that by the delta distance to add to the side dist. So this does make sense. But here it's literally just gonna be the mask is true, false. So then we add side dist plus equals 1.015 or that 0 equals just equals that. And then we do it again. No, we increment map plus equals plus equals I2 1 0 equals our current map position is 4 7, right? I'm gonna bring that down here just so it's there, and then we do that, and then we increment that to 5 7. Now we are here. We just need to do this a couple of times. Well, how does this work? Oh yeah, no, never mind. The side dist is always, it always has a value. So side dist is now going to be that, and this is just going to be times 2. There. And then we check the mask again, equals B2 true, false. And we do it again. Got that. Now we're at 6 7. Oh. 5 6, so now we're here. True, false. And then we do it again. Never seen this before. But now this becomes the same as that. Oh, those are are exactly the same. So now when these two are checked against each other, we're going to get double true. That was not what I was expecting. But I guess it makes sense. I don't think that makes any sense with my math, however, or what we're implementing right now. And then we get 4.0620 times 2. Which is that. But now we've iterated 2 bricks. And then this... Well, as long as we iterate it here, the brick side disk should keep up, right? Because then we go to the right and we go up there, because that was the mask that was from that step here. Let's also type brick plus equals I to 0, 0. And here brick plus equals that. There's that. There it's still that. But here it gets incremented. 1, 1. I think this is kind of unfortunate. Because this wasn't really what I wanted to do. Shouldn't this still be in here? Feels kind of weird to me. Maybe not. What I wanted to do, I guess, would have been more like... more like this, I guess. Because what I want to do is... I want to move over here to the right. And then all I want to do there is increment the lower value, right? And then I want to check here, like, oh, okay, we're in a new brick and this brick is empty. And then I want to move up here via the brick, and then I want to calculate the brick values. So we have to redo this. So it is kind of interesting. We can keep going here first. Because what if this does happen? Now we've moved to the right and we moved up. But no, I don't think it really matters. Because it's the skip that matters. So copy that, make a new one. And then our new target is gonna be 7, 8, 9, 8. Now that's 5, 6. Five squared is 25. 6 squared is 36. 61. And we square root that. That divided by 5. And this divided by 6. This doesn't give me the kind of value I want either. Did I do something wrong now? Yes. What? Yeah. Target is 9-8. So it's... This is 1, right? So then we get this divided by 1. Is that right? I've never seen a value this high before. That doesn't feel like it makes sense either. Am I stupid? Four, 9. That's 5. And 7 and 8. That's 1. How does this delta make any sense? It's because it's the full length, right? Is this why... No. Is this why it leads to like erratic behavior when you're standing straight in an axis? Because if you look at this guy here, if you remove the rotation and you remove the ray position sin time, it doesn't show up quite as much here, but you can see there are like holes everywhere here. And the edges get kind of fuzzy. You see it even better now, I think. Well, it kind of disappears when you increase the resolution. But here, like, you can see it. You can see all the edges get really weird in some places when you're standing exactly there. Now, I don't know if that's what's happening here, but this value just feels super inaccurate. But I don't know if I'm getting a direction correctly either. I think maybe my direction is already normalized. Yeah, it is. That's the problem. Or it's not that it's one problem. It's still not the issue that we're trying to fight, but because you see the screen position is a value from -1 to 1. And the camera plane is 1 on U and 1 on V. This is where it might get stretched a little bit. I don't really know what happens there. Oh, kids, we're doing stupid math. And then here, to the camera direction, gets added the screen position, which is -1 to 1, times camera plane, and that's this, right? And then the same thing here. So all the values are like 1s. And then those 1s get rotated by the camera matrix. So that's probably not going to increment it up to like 2s, 3s, 4s. So I don't really know how this would look in the math. But I think we'll just normalize the value. But it gets weird. Like, isn't it weird to take length from a value that's already normalized using length? That feels super strange. Because if we have 5-1 here and we normalize that, that's gonna end up being what's even 1 squared? It's just 1, dude. So it's gonna be 26 square root. Five divided by holy shit, that's annoying. And that divided by 1. No. No, it's 1 divided by that. Then we get that. And then we truncate it. Like such. And then, like I said, this is where it's weird, isn't it? Taking the length from a normalized value. .9806 squared And that's why before I only did like one. Like instead of doing length radius, I just put 111 there. Because that felt like it made more sense. But I don't know if it makes more sense here. Because I don't know. If this is technically a normalized value, it might not be. But we're gonna get... that and 0.1961 squared. Plus square root. Is really the value we're working with here? Divided by ray direction. Though it might be a way at least to avoid it being ones and because it doesn't seem to like it. Though it's mainly the ray direction that seems to be an issue when it's ones. But if they're normalized, they can't be ones. I think. Unless it's straight up. And that's when it becomes weird. Yeah, we're doing bullshit again. Then we divide this by the ray direction, 0.9806. We get that, 0.8. And then we take that again, divided by 0.1961. 5. That feels like it makes more sense, but it's still kind of 1, 2, 3, 4. Still feels strange. Did I use the right values? Yeah. So that's our new delta distance. No, it's correct. It's correct, because this is going to be the side distance. So it'll start at 400 or at 100, so then we iterate 3 times or 4 times, and then we go up. Yeah, this should make sense. Again, side dist is the exact same value. And side dist plus that. 1.098 0198 times 2. The map position is 5, 7 again. Brick position 0. Again, this is true. Rated to 6. Once again, it is true. Now we're up at 4. And then this is 7, 7. Now, once again, it's going to iterate to the right. This is true, false. Now this returned higher. No, it's still lower. But it doesn't matter. Because here's where the funky part comes in. We move that, and the brick position becomes 1. And this becomes 8. And what we're gonna do now is we're going to check the brick, and the brick is gonna be empty. So instead of moving with the normal side dist, we're just gonna move to the next brick over. And that's just gonna be up. So brick skip, brick position plus equals I2 0 1 equals I2 1 1. Because the brick also has its side distance, so it knows that we've moved over to this brick here, and the next brick I'm going to is the one up there. So it's just gone there now. And what I'm doing now is we're adding to the brick side distance, but that doesn't matter for the calculation. And then we add to the brick map position plus 1. And then we do new map position equals brick position times 8 plus map position modulo 8 equals. So here we have 1 1, so that's gonna be I2 8 8, and our map position is 8 7. Although what we did here was we set the brick map position like that. And the map position is still 7. Right? Because we were in the lower brick and we skipped a brick up to the upper brick. So our map position is 8-7. And then we get this new map position, which is 8-8 plus modulo map position. That's gonna give us plus 0-7. This is already wrong. So how do I do it then? Right? Because I still want... Because potentially the other axes could be at like 3 or 5 or whatever. And we want to maintain that. That's what this was for. And it also is for when you move to the left. Then you'll end up at 7 and then... You want to add that 7, but in this case... Why can't I make it make any sense? It's because I was kind of... I think I was kind of assuming that we moved in from the left, and then we were like moving to the right again. Because then it makes sense, right? I think. But also, since we're moving up, if the X wasn't at 0, if it had been at like 4, which can't happen with only one axis, but it can happen with 3, or with 2 axes, but it can happen with 3. That one axis is like in the middle. That needs to be maintained, but this is really weird. I think we can do this. We take this map position, and then we multiply this by mask. Reverse mask. Because then if we moved up, but it's still not right. But like if we moved up, we move to the right, so we are at x87, and then we skip the brick and we go up, and then the brick gets incremented, and then we do brick map position times 8. So now we have a brick that's at 1 1 times 8, so we get 8 8 plus map position modulo 8. And our map position is still 8 7, so that'll give us 0 7 that we're adding. So now we are at 8 15, which is wrong. But if I do this, I multiply it by the mask, or the reverse mask. The mask will tell us that we moved up, or we moved this axis. Then it won't... it won't add that to the one that moved. But that still presents a problem for if the ray is negative. But how can I add the ray in here? So if I do like minus ray step, I'm not so sure this will work. But no, it won't. So we have brick map, position, or let's just type it. It's going to be 8 plus 7 times reverse mask, which is going to be 0. And the reason I added minus ray step there is because... But it doesn't make sense. But if this... If this was a negative ray, then a minus ray step, that would be +1, right? So then this would turn into adding the 7 instead of getting rid of it. But it doesn't make sense for the others. What happens to a mask if you multiply it with -1? But you can't do that, because you have to convert it to an int3 before you can even multiply it. How can we do this? No, mask. Not mass. It's a mask. With a K. The mask is... when we check which side we need to increment, we get a bool 3. So it's got true, true, false, or true, false, false, or etc. And it lets us tell the rest of the calculation what to add and where at the right time. And that's what I'm trying to use here, because we need to be able to reverse this ray. And what I was doing before, I guess that kind of worked. Oh, this isn't old enough. There. There. It looked like this. It's a total mess. However, what this does not do is it doesn't maintain the map position modulo. We can remove this mask. That just draws it or not, or does the calculation or not at all. And now what happens is that we are at 1, 1, so then our brick map position times 8 gives us 8, 8. And then we add 3.5 plus minus 3.5 times ray step. And what happens there is that if ray step is 1, which means that our ray is positive, then it just gets multiplied with minus 3.5. And then that stays the same. And then it gets added to the 3.5, which means it's now 0. So if the ray is positive, we add 0. If the ray is negative, then brick map is, you know, the multiplication puts us on the wrong side. And then we add 7 that way. But and then we add map pos 8. So this whole thing, I feel like it should be multiplied by the mask. Because this thing, this should only happen if that axis has moved to a new brick. Because then that'll be on either side, always. And then here we will add modulo map position times mask, or reverse mask. And that way the modulo gets added only to the axes that have not moved to another brick. That should make sense. And Now, what we're doing right now is trying to calculate why this is wrong, by the way. Because it's not right. So if we go back to this now and we double check, our brick map position is 8 plus 3.5 plus minus 3.5 times raise step, and that's just gonna be 0 times mask, which is 1. And then that gets... This is not for Legends of Terrestria. This is just a side project. So that's why. I'm just trying to make a voxel game, a 3D voxel game. But a lot of these things that I'm learning here, we could apply, to be perfectly honest. Because the way I'm doing it in Legends of Terrestria is a little bit unnecessary. There's a lot of things I could improve, I think. But it also runs perfectly fine, so it doesn't really matter. Unless it ever starts to matter, which I don't think it will. Because it runs at 400 FPS. So I don't really foresee a lot of issues, to be honest. But there are still... It's still possible to improve it. And then this adds map position modulo 8, which is 7 times 0. So then, now we do end up with 8. Which is correct. Now, just for the heck of it, let's assume that our array is negative. But it kind of doesn't make sense to... Well, okay, let's say we moved it down from 1 to 0 instead. So then our brick map position is going to be 0 plus 3.5 minus 3.5 times raise step, which is negative. Then we'll get plus 7. And then the mask is still negative, so we won't add the map position modulo. So then we get 7. So that should make sense, right? So now we have 8, and we're gonna do a map pos differential. And that's gonna be... eight, I2, new map position, that's 8, minus map position, and that's 7, 8. So then we get I2, 1, 0. And that's our differential. No. The other way around. Yeah, I thought it was weird. There. We get 0, 1, right? Because we moved up here. And then axis differential is map post differential for each axis times delta dist. And that's just gonna be 0, 1 times delta dist equals that. And this is where things go to shit. Here we dist traveled equals 5.0009995. And then you do dist traveled times delta dist. Or divided by delta dist. And that's just gonna give us 1. And that's gonna tell us, oh, we moved 1 up. So then we have, or rather it gives us I2 that says 0, 1. And then I intelligently go down here and add map position to add times ray step, and that's just gonna be map position, which is 7, 8. No, 8, 7 plus equals I2 0 0 1 equals I2 8 8. And then you're like, yeah, that makes sense. Yeah, we're now at 8 8. Yeah, that makes sense. And then we go into sided dist plus equals float 3 or f3 f2 0 1 times delta dist. Oh wait, yeah, map position to add dist traveled. That's where things become weird. Because it's not that. It's actually float 2 like that and like that, divided by delta dist, which is this, right? Maybe now you see what the issue is. So now we get 5.0995 divided by 1.0198. And then it's actually gonna tell us that, yeah, we moved 5 points in X as well. When we moved from here to there. This is 5 points X. So that's where it needs patching. We need to figure out how to get it to just add that little bit. And I'm wondering if you just take the pos differential and you just do divided by 8. Because then that'll give us like our actual amount of steps that we did. Because here we get 0, 1, and then if we take I2 0, 1 divided by I do 8, 8. 1 divided by 8 is 0.125. Yeah, but the reason is that what we get is a value between 0 to 7. And our bricks are always 8 times 8 times 8. And this cannot change unless we reduce it at some point. Because it can't fit in the buffer. Like it's that's the maximum size. The is it this? I guess. Yeah, this is the color index of the voxel. And let's see, how does it work out? You can only have 2048 bits in each index in the structured buffer. And a uint is, or bytes rather, and a uint is 4 bytes. It's 32 bits. So we have 512 times 4 bytes. So that's 2048. So that's as big as it gets. If I wanted to have bigger bricks, I would have to have multiple buffers for that. And I don't want to do that. I don't know if I need to do the struct this way or if I can literally just have a uint and just type uint here. I don't really understand how this works entirely. Someone said that it was like a bad idea to have structs, but I don't know. Felt like BS a little bit. I honestly don't like getting advice from programmers because it's always like, this is bad, and when you ask them why it's bad, it's like there's like no real reason. It's like you might mistype something by accident at some point, and it might give you an error. Like that's the kind of things I always feel it always boils down to. So like I don't know if that matters. Yeah, exactly. That was what I thought as well. But it's at the same time, that's what I read just now. So I don't know. Also, hello, Maestron. How's it going? No, but we're working on the math here, and I'm gonna see if we can get it to work here. Yeah, there are still a lot of things that are also like not caught up. I talked to a guy the other day about that. For example, how generally branching code in shaders is a bad idea. But this is like 10 years old, outdated information, apparently. Like, branches still matter, but compared to how it was 10 years ago, right, like today, it's like if you have an if or else somewhere, it doesn't really make much of a difference at all. And if you look at divergent branching is bad. That's what I'm doing in the other project, like shitloads, I think. But if you look at the branchless voxel raycaster, it was uploaded 2013, and there are tons of people there who are like, holy shit, this was so much better. Like, without all the branching, this is like so much better. Some guy says that it boosted him from like 0.8 FPS to 4 or 5 or something like that, which doesn't really sound that amazing, but... And then the higher up you go in the comments, which are newer comments, people are like, this made like no difference. So... if some threads go on way and other threads go other way, then if it's an actual branch, the GPU will have to do both sides. Yeah. In our other project, I have a compute shader that renders everything. But the way it works is that if it's rendering the background, there's an integer that says render type 1 inside the shader. And then there's an entire section of code there that's like literally the same kind of code that's in all the other render types, but it's like slightly specific only for the background. And then there's render type 1, and you go in there, and that's only for objects and characters, and that's like almost identical again. And that only runs on that. I don't know if that matters. Or if it's like... if there needs to be like else checks and stuff. Because those are all in the same dispatch, right? Like if it's render type 2, it's only render type 2 in that one dispatch. So I don't know if it matters then. Because I assume that's what means that it's not divergent, that all of the paths go in to that branch, right? Anyway, let's try our experimental little code here. So we're taking 0 and 1 and dividing it by 8. Then we get 0 times 0.125. And then what we're doing is we're gonna multiply the delta dist by that instead. Like that. But it's not gonna make sense still. That's what's so annoying. Or it might. No, it won't. But if we get 0.125 times 5.0995, that's not a lot. But that might still be right. Then we get dist traveled. And then we take this down here. And then we divide it by these. But the problem here is that now well, I think I can solve this. So what I was doing was I was just dividing, like I took the differential. So if we were on 7 and we moved to 8, that's 1. And then I multiplied the steps like that. by the delta distance, and that would give us 5 here. And then if I divided that by the delta distance, the axis that we traveled 1 would return 1. But the problem here is that if you traveled on an axis that gives you a big value here, and then you end up dividing the other delta dists that have lower values by that, then it's gonna think that you moved 5 steps in X when you actually moved 0. And so that's what I'm doing here now. I'm getting a fraction, or a fractal, yeah, a fraction of the distance in our y delta, because we didn't move the full 5. We moved 1 out of 8. And then if we take that 1 out of 8, which is 0.637, and we divide that by our delta, that's going to give us 0, 0. And the problem there is that if I just take this now and I try to add that to our map position, first of all, it doesn't increment, or rather, the main issue is that it doesn't increment the y that actually went up. But what I'm thinking is, because I do think this is correct, kind of. But I don't know if I want max here either, but maybe we want max. Yeah, we do want max, because the others are 0. And then what we're getting here is 0, 0. But what we need to do, we need to add plus do I add 1? No. We need to add the original differential. So this should be like that. We need to keep the map plus differential. And this in here should divide by 8. And then down here, when we get the map plus to add, we will add map plus differential times mask. So I foresee a problem with that. What if, because the problem is that if we skipped from, or what I'm afraid of is that if we skipped from the very bottom of this brick, just straight up, and we are coming with the ray like this, then it might already get added here by 1 or by whatever. because that's gonna be this traveled 8. Where the map post differential is gonna be 1, and then it might add 1 here. So if we take this and we multiply this by reverse mask, so 3, and then we go here and we multiply this by 3 normal mask. Because then we'll simply disable the channels here that that we did travel across, and then that'll just get the map cost differential added. In our case, it would get +1, but if we skipped across an entire brick, that would get added all of those, so it would add 8. I think that makes sense. And I guess all that's left is running it and getting very sad when it doesn't work. It's closer. How many layers? Too many parentheses do we have there? Too many. I don't know order of operations, and I don't trust its order of operations. But see, now it's behaving very strangely behind us as well. We've got issues in one direction, and we've got other issues in the other direction. So the question is, where does that come in? This somehow. And I've been asking around, but nobody can help me. The only advice I keep getting is to just make two functions. And I don't understand what they mean at all. Because if I had like one brick ray tracer and one voxel ray tracer, how does that even work? Because the entire crux of the issue right now, like maybe there's some easier way to do it and I'm just stupid. But the issue is getting where we are on the other side of the brick. So like even if I have a brick ray tracer and I ray trace through these bricks, I still need to be able to know where in the brick I am when I switch over to ray tracing with voxels. And that's what I'm not managing now. Like maybe I just need to do this. I've been kind of thinking about it a little bit. There's someone that does this. So maybe if these two lines can do it, then maybe all of my efforts have been in vain. Doing there then? Because like this was honestly how I was kind of imagining that the ray tracing would work in the beginning. And it can kind of do that, but if you're trying to get voxel sides, you have to do the DDA. Length mask. What does that even end up with? That's just the ray distance, right? So that's all he's doing. He's just taking the ray position and he's just multiplying the ray direction by the current length. But that doesn't feel accurate. And the reason is simply because if the last thing you did was add one of these steps, right? Then one of your side disks, or the last side disk, will look like that, like 10. And that's not the actual distance we're at. Right? But they are subtracting delta dist. So maybe that takes that into account. Somehow. I think we have to try this way instead. Like we are so close, but if I can just use these two lines instead. That's gonna be a hell of a lot easier and less heavy as well, because this is a lot of variables. But I don't really understand either, because like, what is it doing? Side dist minus delta dist. This, I feel like the only way to make this make sense is if we are doing this calculation using the brick side dist and brick delta dist after we have multiplied those up by 8. Because I don't know if it makes sense, but it should. Because like our delta dist is the distance that we need to travel to reach to the edge of the voxel. But using the math we have in the beginning, the bricks get the exact same values. Like they have the exact same delta distance. But if we want to be able to convert the brick distance somehow, I still don't see how it makes any sense. Because if Like, if I'm here, and I iterate up here, and I want to get, like, this edge, how does subtracting this get me anything? Like, that'll just get me the distance to the previous step, which was here. I don't get it. But we also it's also the length. But that's literally just the delta distance, isn't it? Because if maybe they're doing some other mask there. No? That's the mask from when they moved a voxel. But I mean, it seems to work somehow. I don't understand, though. Because he's texturing here. And that's by doing that. "3D texture add-on recovering distance and subvoxel intersection position of ray as described in blah blah blah." But let's say... Well, I don't know what... Let's say we are at 50095. And we're getting the length of that, and that's the only thing that's traveled. Then we do square root, root. It's just the same value. So so we're just getting this, and then we're multiplying the ray by that. maybe it does make kind of sense. Because I think you basically raycast from the edge. Like we're not actually raycasting from the bottom left. We're raycasting from here. So if we take this and we then subtract the delta distance, then we get this. And if we're traveling in this direction, so that means that if I'm actually standing here, then our side dist has already intersected this. So if that is something, then the pure side dist value is what we should use to read the UV of where we intersected this, I guess. And if you do this, ray position plus ray direction, times 5 point, what was it? Then we get 0.9806 times 5.0995 plus 4, so that's 9, kind of. That's 1. Plus ray position. Wait. Yeah, I already added that. But that would be 8 then. Oh no, that was incorrect. Or less. Well, no, I was kind of using a meme variable there. This would be 7. So we would actually get 7, 8 there. So if you do the minus delta dist, then you get the front side of what you want, what you intersected, I guess. I'm still having a hard time understanding how I can use this to resume the ray trace, because that's what I need to do. That's the goal here. Just resuming the ray trace after we've skipped a brick. That is the goal. Maybe my math is almost there, but I don't know where the issue would be anymore. Again. Oh, hello. That might have been wrong. This is also wrong, I think. Ah! Oh, so close now! For fuck's sake! Just fucking work already! I'll be right back. All right. There's something else to note here, and that's that it's running like shit. Like it runs really, really badly right now. It runs almost like without doing skips at all. The mask kind of weirds me out a bit. Because I feel like it's gonna overshoot. Because, for example, the fact that it's using well, it makes sense here, right? Because it's using the mask. And because it's using the mask, that means that even if we just moved up to the low frequency delta and we just added like 5 and the other ones are like 1.6, 1.2, it doesn't matter because he's just subtracting that. And then he's using the previous value because he's checking where the edge of the voxel that he just entered is. So it might work. Still a little bit curious why this doesn't work though. Maybe it's this. This is such bullshit. But I think maybe we'll give up on this math line. Try doing the other one instead. What we may be able to figure out here is how many raise steps we've taken. And if we can recover how many raise steps we've taken in each direction, then we can just multiply that by side dist or by delta dist and add to side dist, and then we have our value again. But I think what we have to do, because basically what happens is that once this ray gets cast, we are at the edge already. So we're already at the first intersection, right? When we start, we're here. Even if we're starting here, we start there. And I kind of feel like I should store our initial side list in a different value. And then the problem is, once we iterate into the next brick, right? That puts us at the other edge of the brick. Distance-wise. So we do need to subtract the brick, the previous brick, and then we need to add one voxel delta in, because that will tell us where we are. That kind of makes sense. And then same here. After we've moved up here. But it's still weird. But maybe not really. But it still kind of is. Well, no, not necessarily. If we move from here to here, then the X is going to be here, right? And then if we increment the Y, then we're up here. We were already up here though, before we incremented up there. So if we decrement this back down so that we're here, and then we pop ourselves up one step in the voxel distance, that might just take us to the proper distance here. Yeah. But then the question is, I feel like you kind of want a boolean then, or something. That tells us that we were in a brick. Because if we were in a brick, we don't want to recalculate this all the time. If we start out in traverse brick, we just want to be able to start going there. And this should only happen if exited brick is true, for example. Then we do that. And the reason for that is that, first of all, so we don't have to recalculate this every single time we exit or enter a brick. We only want to do this when we need to reconstitute our length or our distance to a voxel position, which means if we have been traveling through voxels or through bricks and we find a brick with voxels, then we need to do this. But otherwise, like if we travel to the next voxel, we don't want to have to do this again, because that's very wasteful. And also probably doesn't make any sense. We set that to true there, and then we set it to false. I don't want to back up. Before we keep changing more. So there is a problem. What was it that I installed? Yeah, I installed some custom pipeline stuff. For RP library. Yeah, customize a scriptable render pipeline. And the problem with that is that it's 12 gigabytes in size. But is this in use at all? I need permissions, yeah? Okay. I need permissions from myself, and I can't give it to myself. Fucking hate Windows so much. Absolute piece of shit. And it's completely impossible to understand how to change permissions. Read and execute. Okay, is that me? Can you let me change things? But I'm logged in as administrator. Oh, oh, it says I'm an administrator. And administrators have full permission, so what's the problem? Okay, how about we do this? We go into command prompt. How do you delete from the command prompt? Dell graphics. Are you sure? Yeah. Now we're just waiting for it to happen. Couldn't delete all of it? Okay, I guess. Oh, why do I have to fight with this bullshit? Come on. I'm just gonna copy everything except for graphics. Now. Because I mean, I do kind of want to have the core RP library installed, but I don't want 11 gigabytes of GitHub files in my folder. Yeah, I don't use Git. I should set up Git on this project though. Just so I get used to it more. Now we have copied all of that. And we no longer need this. We don't need this. We don't need this. We don't need this. We don't need this. All we need is, I want to save side disk float 3. There. And now I actually want brick delta disk because we are just going to multiply it by 8, and the brick side disk is also just going to be multiplied by 8. I don't know if it'll get weird if I multiply it by that, so let's just multiply it by the delta disk times 8. And the only reason for that is, again, so that... Well, I'm not sure if that makes sense, but... So that the brick's distance values will translate into... Like the brick delta disk should be the same as 8 delta disks, because we've traveled across the entire thing, right? Now we just need to remember what I've been babbling about. Okay. So the length we get is going to be the brick side dist minus brick delta dist. And then the distance is going to be ray position plus ray direction times d. But what we really want is just this, right? Yeah. What we want to get is the amount of steps we've taken. So if we take ray direction times distance, and we divide it by delta distance. Does that make sense? No. We already have the number. This is the number already, right? We just need to floor it. And that's how many indices we've incremented there. And then we do side dist equals side dist stored plus delta dist times dst plus float 3 mask times delta dist. And that means map position equals int3 ray position plus int3 delta dist. No. int3 dst plus int3 mask. No mask there. Well, yes, plus int3 mask times ray step. This also needs to be, which means we can do it like that. We plus the mask and the DST together, and then multiply that with the ray step. And we do that before there. So we need to reconstitute the voxel position before we can check voxel. If exited brick, then what'll we do? We'll do new brick equals get brick map position times 8. Else we'll do this. It's new at least. Hello, chocolate. Nope. We're not winning at all. Not going so well. Don't really understand how we get to the black. Hmm. I'm trying to increment the brick mainly, and then reconstitute the voxel position whenever we enter somewhere with voxels, but we need the side disk, don't we? And what does that mean? That means we can't add the side disk back in, because if we are including the side disk, which is the distance from the ray to the side of the brick, I can't subtract that, because the side disk value of the brick would include, like, you know, anything from 1 to like 7 steps in the voxel space. So that makes no sense. So we just have to include the whole side disk and simply assume that that side disk is part of the delta distance there, and then just multiply it back up again by dst. Oh, come on! Why is it black too? Like, why doesn't it work in this direction? Does it not work downwards either then? I don't get it. Why doesn't it work there and there only? Like, that's just the X. Oh, maybe it doesn't work here too. No? Okay, well, I mean, kind of. The X is weird, but the Z and the Y seems fine. Oh, wait, I see what's happening. I don't know if I need to floor it there, but we need to abs it. Because otherwise the side disk will get negative. And it can't be negative. And here as well. All right, let's rethink this. So we get the length from the previous side of the brick. And then we take the ray direction times d. Let's just abs this. Instead of anything, doing a floor or anything. Yes. Yeah. 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 We need the decimal to take into account the side disk that's missing. And then we can just delete the abs there. And then there we just add float 3 mask times delta dist. And map position grabs the ray position, adds the DST is already absed, so all we need to do is add the DST and the mask together and then ray step multiply them. And it still doesn't work. Fuck off! Oh, I'm so tired! I'm so tired. You're dead? Well, then fix it for me, Dad. Why do I have a circle all over the place? And why are we seeing... Why am I seeing the floor again over there? Like the floor is repeating. Not funny. I don't know if this makes any sense either. Just multiplying the delta dist. But it's so strange. So weird. But this should be delta dist, because that's the distance that we need. Like, it's always been right there. Assuming that 8 is a value at all that makes any sense. We can try doing cs test.x there and there. But none of these values really seem to make much of a difference. I'm still hopping. Like, the fact that it's black, that means that we've stepped past the step limit. And the fact that I can go this close and we're still stepping past the step limit. And even like over here, this being the step limit, it's even more absurd. Because this direction, this should be back. Like, right now, we are basically at the edge, and yet it's still... because when it goes below 0 here, it should draw blue, because it's outside of bounds. So it should not draw black. So somehow it's doing 500 steps on 10 voxel space. That's weird. And map position, originally that's how we get it. We just take the ray position. Or shouldn't be needed. And then we have the DST times ray step. That's just how far it is. I don't get it, man. I don't get it. Do I need this? Because he does something up here that I don't understand. But no, I think this literally means checker. Like he's making a checker pattern. It's not something that checks something. Isn't this strange? What is happening here? I've never seen anything like it. He types vec3 delta dist, and then he instantly just does a bracket. How do you bracket a vector 3 delta dist? And it even has like an end there. Or did he just do it so that he can expand this? Yeah, okay. Yeah, never mind. Delta dist equals 1 divided by ab's ray direction. Different. Let's try that. I think it'll have the same outcome, but... I don't know if this makes any sense, but... the logic should still be the same, even if I multiply it by 8. Yo? I see some small issue. Yo? Yo, yo, yo? I wonder what the hell fixed it. That's still whatever. Did the radiator normalize? Okay. I just wanted to see if this would work. But not really. With the normalized ray direction. Alright, well that's nice. The only issue is this, right? It's showing too much. But it's kind of weird. Because I think I should do this. But it's like, it doesn't want me to. Wait. I removed one here. Plus. Floor 3 mask times delta dist. That's already being added there, right? No, this needs a plus mask as well. Yo? Does it work? No. It's really close, but we've got glitches. See over there in the corner? It's kind of glitching in the intersection there. And things kind of jump around a bit. You see there's like an integer error. What if we add the ray position and the DST together as floats, no flooring, and then we do int3 there. That made it worse. How did that make it worse? Go fuck yourself. ray position should be floored. Because the decimals on the ray position is already accounted for in the side disks. Still kind of weird. You're so fucking close now, dude. It doesn't run very well, though. Oh. That's no good. For some reason it works up there. I'm worried that it's simply not accurate enough. But I don't know if that's the issue. still does it. It's this integer wobble. That's an integer wobble for sure. Why is it happening? No, it just doesn't want to go away. No. The it's almost working, but it's not working correctly. Like you can see, it's there's no black, but it's like wobbling and it's choppy and just don't really get it. I have an idea. What if we do this? Minus side dist stored. And then here we have side dist stored plus. Nope, it's even worse. Fuck off! Oh my god. Why would I get this wobble? I don't understand. Where did I put it? Question is, do we normalize it here or here? Before or after the camera matrix? No difference. Fuck you. Fuck you all. It also runs incredibly poorly. I thought it would run a lot better, since it ran pretty well. Some of the times earlier when it ran really badly, or when it didn't work, but I guess it was just exiting early. Look, if I can just get it to work. Then we can try to make it run better after that, but... Just work, please. It probably doesn't work like this. Why wouldn't that work? So it kind of worked when I multiplied the bricks side disk by 8, but it doesn't work when I divide the side disk by 8. Is there any reason for that? Doesn't look like it, it just doesn't work. Oh, I see it. Have a parentheses. Oh, fuck off. Alright, what if we simply do this and they're both equal? And then up here, when we add the ray directions and everything, we multiply DST by 8. Oh, still the same thing there. Get it. What if we do that and then we do mask check and then we do side dist equals this shit. It doesn't even fix the issue there. What am I listening to? Bye bye. I still believe in this though. We multiply brick delta by up by 8 again. Multiply this one by 8. I still believe in subtracting side dist stored. Brick side dist stored. No, normal side dist stored. Runs super fast now though. The walls are closing in on me. I don't really understand how that makes such a big difference. Oh, wait. It's broken now there. So some of the things I was working on could have worked, but no, this doesn't work. I don't know if this is fixable. That's the thing. I don't really get it. I don't understand why it does this. More weave songs to delete. It's not good enough. It's not good enough. That's not going so well. Close, but it's not good enough. Yeah, I was reading the comments, and some people solved the distance problem. This is what he's doing. But I already tried that. Side dist minus delta dist times mask. And then he did slash length array there. But I don't see how it didn't make any difference. Like it still has all the glitches. So this just is not a solution either. I don't understand why it's so choppy, mainly. Like that's what triggers me the most. It's like chopping around. It's not smooth. And that's making me feel like something is just straight up wrong. Like I'm flooring something that shouldn't be floored, which I've already tried changing all of that. But it's still choppy. This should absolutely be floored. But so should ray position. Like, both of these should be floored. If it's anything, I don't trust this. I'm just frantically deleting and changing things now. It's terrible. I don't want to hydrate. I want to die. But we should stop here. Yeah, that's a schmood. Oh. Yeah. The first comment here is, this is an interesting DDA, but it doesn't keep track of the precise subcell location. Extracting it back out from side dist and delta dist would involve ray step and some fudging around. I started on it and balked. My DDA is the one I stole/salvaged anyway. Take pains to track the fraction, which really helps at the end. Since I already have that working, there's not a lot of upside to solving the texturing here. So that's the issue, right? It's just not accurate. And I don't really know how to do that. But what I can do is, we can stop here because it's almost time to stop anyway, but I can, even though it's almost impossible to find anything in my opinion, I can try to find some information on texturing with a raycaster, or with DDA raycasting specifically, because texturing and figuring out which voxel we're on is the same thing. Like, it's the exact same thing. So if I can get an accurate texture position, then I can get an accurate voxel position. So that's what I need to look into, I think. Because something is missing, but this is obviously a much better approach than I had, because that didn't work at all. Not even a little bit. Move that back there. But this is unnecessary, because this is the ray direction is already normalized, so that doesn't matter. Hmm. Textured raycaster. Perp wall distance. Well, any breakthroughs? Yes and no. It still doesn't work, but it looks a lot better. As you can see over there on the right, the it's jagged, so we don't have correct accuracy, and it kind of lags around and it's jaggy. See, it kind of moves around in large steps. It's weird. I don't really understand. I don't understand that. Like, that makes no sense to me why it does that. It's like it's jumping back and forth as well. So I kind of understand, because the side disc is not accurate, because it's not enough of it's not enough of an indicator of the exact distance we've traveled. Because when we add, like, the y-axis, for example, that can be 1. And then we add 1 again, and then 1 again. And then we add the x-axis, and it adds 5 in one go. And then if we check, when we add that 5, if that's when we need to check what distance we're at, it's not even remotely close. Like, it's just like a huge jump in distance. And then you go back to the other lower ones, and then you increment those. So it's really weird. I wonder if you can maybe get some kind of like average or something. Because here what it's doing is it's giving us a length, but what if we just do something like this for shits and giggles? I don't know what it's called when you subtracted this. No? D equals. Why can't I set D? Fuck off. And then we do subtracted this.x plus subtracted this.y plus subtracted this.z. There's no way this is gonna work though. Get an average. Nah. What about if we get a length from it? No, I'm just trying random things. These have no basis in any kind of math. I can't see which server it is. I've posted it in like 5 different servers. I don't. It doesn't show what Discord server it is. It just shows me that I don't have access to this text channel. Hmm. Sure, why not? I'm in like 8 different big servers already, but it's still hard to get anyone who knows what they're talking about or anyone who wants to help. Yeah, no. I'm gonna go and read this paper on raycasting and probably die. Yeah, it is kind of hard to, and it's kind of annoying because I usually do things, or at least things that I feel most people aren't doing. So it's almost impossible to find anything that is related. But yeah, I'll see you guys later. Thanks for hanging. Have a good night. Bye bye.